Hello calculus students and general seekers of truth. Welcome to the video on differential equations and in particular solving for the constant. All right, and I am going to focus this video on part C here. This is an old FRQ, I think it's from 2010, so you can look that up and see what the solution actually is. But I'm actually going to look at in the part C and I'm going to solve it incorrectly at first, and then hopefully we can find the error, and then I'll show you why the error was wrong and how to correct it. So we're going to find a particular solution for this differential equation that goes through the point 1, 2. So we want to separate our variables, and we get dy over y cubed is equal to x dx. And we integrate both sides. So over on the left side, this is really y to the negative third dy, because we really just have 1 over y cubed. And over here we have still the integral of x dx. The antiderivative of y to the negative third is y to the negative second times negative 1/2. Over here you have 1/2 x squared plus some constant. Okay? And we're going to continue moving forward and solving for y, so because we want to get y by itself here. So multiply everything by -2. And so if I multiply this by -2, I get just 1 in front. This I get -1, and this constant by -2, it's -2c, but that's still a constant. And then in order to get y by itself, we are going to raise both sides to the -1/2. So we get y is equal to and -1/2 is really equal to 1 over the square root of x squared plus c. Okay? And this is the general solution, and we're done with that. Now we have to figure out what is the specific solution for when x is equal to 1 and y is equal to 2. Now I often solve the problem by finding c in the intermediate steps. And I'm going to show you why in this particular case we have to be a little bit more careful. So if I use this step right here, we plug in 2 for y and 1 for x. We end up with -1/2 times 2 to the negative second power is equal to 1/2 times 1 to the second power. And over here this gives us -1/8. And over here this gives us 1 plus c. I'm sorry, 1/2 plus c. So I add -1/2 to both sides, and that's -4/8, so we have -5/8 equals c. And then we go back and we make the substitution, and we see that y is equal to 1 over the square root of -x squared minus 5/8. And it seems that this is correct, but it's actually wrong, because if we actually try plugging in 1 into this, we get 1 over the square root of -1 minus 5/8. Okay, then this is a non-real answer. This right here is some other negative number, so this is actually wrong. Okay, now let's look back at our work. Why is that? I assure you that all of the calculus and algebra over here is correct. You should check it out and verify it for yourself, but I'm fully confident that that is correct. I'm also confident that over here the arithmetic and the algebra that we solved is also correct, and c does in fact come out to be -5/8. What is the issue here is going from this step to this step, okay? Because this c is a different value than this c. We often say that it's just a constant, and that's true, but these are two different constants. This constant is something, And in order to go from this constant to this one, you have to multiply by -2. So here's the issue, right? Because if you would continue to solve it out through the end, you would get a different result. We can't take this number and plug it into here and say that that's correct. So the correct exact solution, we really have to go back to this step. -1/2 y to the -1/2 is equal to 1/2 x squared minus 5/8. Multiply everything by -2. And -2 times 5/8 is positive 10/8 or 5/4. Then we can raise both sides to the -2nd power, and we get this is equal to 1 over the square root of -x squared plus 5/4. So the moral of the story here is it's okay for you to solve for the constant at any particular step, but you have to make sure that after you solve for that constant, you isolate the variable from that point on. Or you can solve for the constant in the very last step if that works better for you. In this case, I don't think it makes much difference in terms of difficulty, whichever way you go, but you can't mix these two. You can only mix them if you can only do what we did before if you already have y by itself. If you have an expression that's a more complicated version of y, then this is going to present an issue to you. So that's all for that. Hopefully you get you understand the pitfall that's possible here, and it's not to say that you can't do it certain ways. You just have to be careful how you do it. And part of this class, part of the learning math here is understanding when to apply which methods. Thank you for watching. Have a wonderful day.